We're going to create right triangles on the coordinate plane. We're going to start with the first quadrant. When we do this, I'm going to draw a terminal side of the angle in quadrant 1. Then I'm going to draw a perpendicular vertical leg to the horizontal leg that is on the x-axis. So I've got this horizontal length that I'm going to call x. And I'm going to have this vertical length that we'll call y. And that's going to allow me on the coordinate plane to have an ordered pair x comma y, which is going to be very interesting later on. And a hypotenuse that I'm going to call r. I'm going to call it r because eventually it's going to be part of a circle that has a radius, and that's going to end up being in the radius. But we don't need to worry about what r stands for at this exact moment in time. We just know that we're going to call it r. So we've got the horizontal leg is x, the vertical leg is y, and the hypotenuse is r. And let's call this angle that is made with the x-axis theta. So we're going to have a positive x, a positive y when we're in quadrant 1. It's a beautiful, beautiful picture. Okay, let's move to quadrant 2. When we go to quadrant 2, again, I'm just going to pick anywhere to draw a terminal side of an angle. So here's my angle in standard position, right? But this ordered pair for this angle in standard position is going to have to come from a vertical that we make with the horizontal in quadrant 2. Now when we do that, the length along that horizontal leg is going to be a positive length, but for the ordered pair, we're going to have a negative x. So negative is going to tell us for x that we're in quadrant 2 with a positive y, because the y value is above the x-axis. So our ordered pair here would be negative x comma positive y. Still a length of x, a length of y, and once again we have a hypotenuse that has a length r. And in quadrant 3, we're going to draw a terminal side anywhere in quadrant 3, along with a vertical leg to the x-axis so that we can make that triangle. And you know, I forgot to put the theta with the x-axis. So here I'm going to, with blue, draw the horizontal leg. That is negative because we're going to the left of the origin. And we'll have a vertical leg, which is y, but it's negative because we're going below the x-axis. And then, of course, we'll have our hypotenuse r. Now, our angle theta is going to be the angle that's made with the origin and the x-axis. The origin and the x-axis, the origin and the x-axis. And our last will be in quadrant 4. Any terminal side in angle 4. See, here we go. Look, this right here is our angle in standard position. We have a terminal side in angle 4, or in quadrant 4, not angle 4, quadrant 4. I don't know how many times I said angle. I meant to say quadrant. Quadrant 4. Then we have our vertical leg. So we have our horizontal leg, which seems to always be, no matter what quadrant we're in, always along the x-axis. So our horizontal leg is x, and our vertical leg is y. Now, in this case, y is going to be negative because the y is below the x-axis. Positive x because we're to the right of the origin. And our angle is going to be, our angle theta for the right triangle is going to be the acute angle that is created by the origin and the x-axis. The hypotenuse is always r. And if we look at each one of these triangles, x squared plus y squared, our leg squared plus the other leg squared, so the horizontal leg squared plus the vertical leg squared, is going to equal the hypotenuse squared, which is going to give us r is equal to the square root of x squared plus y squared. So we first must find the x and y values, square each of them, add that sum together, and then take the square root. R is always, I don't always like to say always, but in this case I'm saying always with a capital letter. Capital letters for all. That's yelling. It's so true. I want to just scream it from the mountaintops. R is always positive. Okay, so two important formulas. Well, one important formula, one important fact. R is equal to the square root of x squared plus y squared, and the important fact is that R is always positive. So now let's look at any one of our triangles. We'll look at our first triangle right here. We've got from theta, our reference angle, y is the opposite side. From theta, our right triangle, draw an arrow going to the opposite side, y is the opposite side. From quadrant 3, theta, draw an arrow going to the opposite side, that's y. And quadrant 4, drawing an arrow to the opposite side, we have y. So whether you have a positive y or a negative y, the opposite side, which we know the sine of theta is equal to the opposite over the hypotenuse, the opposite side is always y. And the hypotenuse is always r. The hypotenuse in every case was r. So if y is the opposite side in each case, then x is going to be the adjacent leg. The adjacent leg, the adjacent side, adjacent. And you can see the adjacent leg is always x. So the cosine of theta will equal x over r. And the tangent of theta is always opposite over adjacent, so that is always going to be y over x. And then the cosecant of theta is the reciprocal of sine of theta, so it's r over y. The secant of theta is r over x, and the cotangent of theta is x over y. This is another important factual rectangular section of our notes. We'll want to memorize this, so we'll want to create flashcards, which I will help you with in a minute. But first I want to show you why it's so important that you know these off the top of your head, because we're going to start doing some calculations. So let me show you how we apply this. We want to find the other 5 trig values given the sine of theta is negative 2 over the square root of 5, and we are in quadrant 3. So the first thing I'm going to do is draw a picture. Quadrant 3, we're going to have a terminal side. I don't have to draw it for accuracy right now. Just know that my terminal side, which is r, is in quadrant 3. Sine of theta opposite, that's going to be your y value. So your y value is 2, and your x value is unknown, and your hypotenuse, which is r, is equal to 5. So in quadrant 3, x is negative and y is negative. So the sine of theta equaling negative 2 over 5, the sine of theta is y over r. This negative is going to move up to the numerator with the 2. And we are going to have y equals -2, r is equal to +5, and x is unknown. So we need to first find x, y, and r. When you know that the sine of theta is y over r, you know that what you're looking for is x. So x squared plus y squared, -2 squared is 4. I better put that, -2 squared, equals r squared, which is 5 squared. So x squared plus 4 equals 25. X squared equals 21. X is equal to the square root of 21. So we're going to write that right there, the square root of 21. And now we get to find the sine of theta, which is already given, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So the sine of theta is given. It is -2 over 5. The cosine of theta is x over r. Very important that you know what these are. Cosine of theta is x over r. Sine of theta is y over r. Tangent of theta is y over x. If you can get those memorized, it's going to make your life so much easier. Cosine of theta is x over r. There is something missing here. X is negative. How do I know that x is negative? Because we are in quadrant 3. So our answer for cosine of theta is negative square root of 21 over 5. The tangent of theta is -2 over negative square root of 21, which is 2 over the square root of 21, which rationalized is 2 times the square root of 21 over 21. The cosecant of theta, I'll do these in gold. Cosecant of theta is -5 over 2. Secant of theta is -5 over the square root of 21, which rationalizes to be -5 square root of 21 over 21. And the cotangent of theta is the square root of 21 over 2. So we have sine, cosine, cosecant, and secant all negative values, and the tangent and cotangent are positive values. That is true. All of that is correct. I'm going to come through here and I'm going to box the answers. I really did not need to find sine of theta since it was given, but I boxed it anyway so that I have all 6 trig functions boxed. Okay, let's try one more example. We're going to do some more examples, but we're going to try one more example before we head to another video. Cosecant of theta is equal to 4. We're in quadrant 2. In quadrant 2, we have a negative x and a positive y. The cosecant of theta, if we have our facts memorized, we know that the cosecant of theta is r over y. That is something that, again, will be very helpful for you to know. R over y. So the cosecant of theta is equal to r over y, and 4 can be written as 4 over 1. So we have x is unknown, y is 1, and r is 4. Now, x is going to be negative, y is going to be positive, and r is always positive. And I found that by looking right here at the ordered pair. X is unknown, y is 1, r is 4. We can find x by saying x squared plus y squared equals r squared. X squared equals 15. X equals the square root of 15. And it's going to be negative. So we will have a negative square root of 15. Now I think I'm ready for the sine of theta, the cosine of theta, the tangent of theta, and each of its reciprocal functions. The cosecant of theta, secant of theta, and cotangent of theta. The sine of theta is y over r, so that is 1 over 4. The cosine of theta is x over r, so that's negative square root of 15 over 4. And the tangent of theta is y over x, which is 1 over negative square root of 15, but I'm going to put that negative in the numerator because fractions look better with their negatives in the numerator, and I'm going to actually rationalize that denominator, which gives me negative square root of 15 over 15. Cosecant of theta is 4, which was given. Secant of theta is negative 4 over the square root of 15, which can be rationalized. Negative 4 square root of 15 over 15. And the cotangent of theta is negative square root of 15. I just went back here and wrote the reciprocal. So our answers: sine of theta, cosine of theta, tangent of theta, cotangent of theta, and secant of theta. And of course, this one was given information.